Bleiben wir beim Thema Security.
Let's stick with the topic security. Specific implementation of Industry 4.0, big data and IIoT, they all have one thing in common. Do you know that thing they have in common? The one they have in common is that data is not processed where they are created, but also at remote, or is sent to remote parties and third parties. And this distribution should not get out of hand or out of control, and therefore it's always important to have a very stable security concept if the passwords are hacked. CODESYS has done a lot throughout the last 2 years in order to be able to produce and provide a very good security. We have implemented several features for the runtime and the softwares, but we do receive only just a little feedback from the field. We do think that the topic security has not reached you or the clients entirely. In order to improve the situation, I'm going to show you some security features in CODESYS, but mentioning and showing you specific examples. In the second part of my presentation, I show you the future. The future, how you will be well protected in the CODESYS world. Before we start, we need to cover theory as well, theory about attack sceneries and security levels. Security levels or layers are similar to SEAL 1, 2, 4, and they are also covered by an IEC standard, which is the IEC standard 62443, and Professor Dr. Fröhlich actually introduced that to you. Thank you very much for that. Security level 1, SL1. In this respect, we do not talk about an attack. It's just a failure of functions. It can be a hard disk that fails to work, or it can also be a misentry, a wrong entry by the user, but it's still accidental. Security level 2 is a proper attack with only a little criminal energy. It might be the case that it's a worker which is not satisfied and wants to sabotage the machine, or it is somebody that gets the password right and wants to get data and access to data. With security level 3, it's getting interesting. Now a hacker is involved. The hacker has expert knowledge. He's got a high share of criminal energy. He wants to get money, wants to do something. And therefore, this person uses hacker tools. The person also has the opportunity to use security exploits that exploit and take advantage of loopholes, security loopholes. Security level 4, we do have infinite resources. We do have a distributed expert knowledge through many disciplines, and it might be the case that there is insider information received by whatever means. Well, security level 4, I always think about criminals in banana republics or also intelligence agencies. That's actually how you can imagine that. Enough of theory. Let's have a look at security level 1 problems in CODESYS and what we can do. Here is the threat, a failure of the controller unit. If the coffee drops into the controller, then we cannot do a lot from the side of the software, but we do offer backup and restore. And with this feature, you can make a backup of the controller, and later on, if as soon as the coffee was in the controller, you can restore the data in a new controller. The next threat is operating error. Just imagine remote maintenance of the wind park is going smoothly, and then your cat actually jumps on the F9 button or key and sets a breakpoint. Now it can get uncomfortable. So what do we offer? We do offer the operating mode. So if you had set that to operational, the controller would not activate this breakpoint, and there would be no reason for your pulse to increase. Another topic on security level 1 level is logging onto the wrong controller. This is not really comfortable, and it can happen because there are many same names of the controllers because the names have been cloned. So what do we offer? The interactive login. And the serial number is then requested in this login. So that means you only access the controller you want to access. Next threat, unauthorized access. What can we do about that? Well, very easy. Just activate user management. User management does exist for a certain process, but it's also important to activate it on the controller. So if you activate it on the controller, you actually prevent bad guys or villains to access it. It also helps to pretend, well, some funny colleagues to send you pictures of cats, funny cats whatsoever. That was security level 2, actually. Now let's talk about hackers. What can we do? Man in the middle, Professor Dr. Fröhlich mentioned it already. Here, the hacker actually appears on the communication path. He wants to get the data between the development environment and the controller. What can we do? Well, communicate in an encrypted way so that the hacker cannot read the communication. It's very easy to activate that in CODESYS. You do see the yellow line there. And with that, the man in the middle cannot read what you say. We do offer encryption according to industry standard TLS 1.2. Security level 3 goes a bit further with regards to data theft. So what can we do? We do have the IEC project on the one hand. So what you can do against theft of source code is to encrypt data. There's no other means. So what we do is we encrypt the project file. So we have generated many opportunities. You can either set a Vibo dongle, you can use certificates, or you can set a password. It's actually up to you what you want to have. And if you want to increase the authenticity of your project, so if you want to make sure who the editor was, then you can prevent manipulation of the source code by activating the signature of the project. That also is carried out by certificates. That was the IEC side, ID side, so let's have a look at the controller side. The same problems may occur there. Theft of boot application, that costs a lot of money. So if one boot application is stolen, you will never ever get that back. And be careful there, encrypt as well. So what we can offer is we can encrypt the boot application and the download using certificates. So it's encrypted by the public key of the controller, and only the controller has the private key and can then decrypt the controller or the application. If you want to make sure that the controller only accepts code from you, then you can switch off the manipulation by signing the download and the boot application. That also happens on a certificate level. So you actually signed a certificate with the boot application. We haven't had an overview of the security features, and we do think it's a very good starting point in order to get hold of this IIoT topic. But if you have many controllers, you might lose the overview of all of them. You don't know which controller or which device has which functions activated. And you do not know which features do you need. And that is something we want to change in future. Our vision is a tool-supported security analysis and also a configuration which can be carried out very easily on a central spot, which also is a bit of fun. What we did is we have created a new threat modeling editor. You can model or edit a system, and you can also configure it through wiring them accordingly. Using this wiring, there is an analysis carried out leading to a report that actually states which security problems are there and which ones need to be solved. So which is a very good basis to take certain decisions. A very good thing with CODESYS is that every changes is distributed on CODESYS. So if you have, for example, the encryption activated, then this is also distributed to all other controllers, so you only have to do it once. So let's have a look at how it looks like in CODESYS. Let's start with an easy example. That's the hardware setup for my second example. It's a bit more ambitious project. In the first example, I want to show you how do we at CODESYS in the office deal with controllers every day. I do have a simple IEC project. You see there's only one controller incorporated, not a lot of logics behind. The controller JS is my controller, simple IEC project. We add a new editor now. So we right-click there, add object, threat modeling, click on that, and then add. Okay, now I have an empty editor surface where I can start to draw. I do have a toolbox. I could just drag and drop the controllers into the editor. As we deal with a specific project, I can only use that button and get the controller into the editor. So now I do have my controller in the editor. So what is the next thing you usually have? Well, it's an Ethernet switch. I could rename them if I wanted to, but that's okay. Then I do have my developer laptop. That one here represents that one. And I do have a local user. Let's say that's the CODESYS development team, CODESYS dev team. You see, the local user doesn't have to be one person. It can also be a group of persons. Now we do have 4 individual components, and let's have a look at how the threat situation is. Right-click on the model, and then we receive a report. It offers a quite good overview. We only have 7 problems to address. On the left-hand side, you do see the source. Where does the threat come from? And then there is a state where you can see whether the problem has been settled or not, or whether we have to deal with it. And on the right-hand side, you see a description of the problem and how you can solve it. The description is still work in progress. I'm sure there is room for improvement. We see here that we have several problems. One is solved already. Audit software, so my controller actually has the current firmware installed. So I can just put that here, can hide it here. then I do see my controller, that my controller could have hardware failure. Well, that's not a problem because we do not have a production system in-house. So if the hardware fails, my pulse doesn't rise. You do see the IT components which are connected as well. They are shown in the report as well, because you have to consider that, because you have to take somebody in charge that deals with the topic of package inspection, firewall, virus scanner, etc. Everything needs to be covered and dealt with. In our office, we do have a very strong IT department. That means I just set the threat of the Ethernet switch and laptop to ignore, but I will state why, and I just enter IT. I can't configure it, but I can deactivate it with a description or an explanation. Let's get back to the report. Now I see we only have one problem. Well, it doesn't make my hands sweat or sweaty. Probably it looks as if it's not difficult. But the reason for that is that the components are still individual and not connected. So that's what we have to do. So the controller is connected to the switch is connected to the laptop, and the Ethernet plug or socket, and the user is connected to the laptop. So what about the report now? We do have now two more or additional problems. The dev team can cause two problems: unauthorized access and operating mistakes. I'd say operator mistakes is not so critical in our office because we do not have production in our house. Unauthorized access, that is something I would like to prevent, so that my funny colleagues cannot send some funny pictures to my computer. So let's get back to the editor. Let's select the controller and let's activate the means against unauthorized access. Now we've activated a user management on the controller. If that controller was connected to the software, then it would be ready. So what we have to do now is we have to configure the user dev team or the users. I can select the certificates for user management here. A dialog opens up. That's actually a standard functionality of CODESYS. And what I can do now is I can just get out the certificates from the Windows Certificate Store. So I just include Mr. Kettele, then we also have Mr. Greising. And well, I should not forget myself, because otherwise I will not have access to my controller. Now we have a very nice configuration. User management is finished. That's a bit of future vision, because we cannot use certificates for user management, but that is actually what we want to achieve. So you do receive the certificates from your IT, and you just click the user management as you want it, so you adjust it as you want it. Let's have a look at the threat report again. So the problem or the issue with the unauthorized access has been solved. What we do not have here yet is data that can be modeled or processed. So typically, you do have an IEC project on the laptop and on the controller a boot application. So let's add data to this model here. We have this generic object for data. Well, we do have the file here, and I do call it boot application. It's separated, and having it separately, there is no influence on the controller or any other thing whatsoever. But I have to now add the connection to the controller, and now actually, because of this connection, a new problem should be shown and displayed. Nothing happens. Well, you see, there is no additional threat. That, of course, is because of the CODESYS dev team. Well, Mr. Greising, Mr. Catalan, me, myself, we are absolutely trustworthy, so we are not a threat. So we do need a new participant now, a new player. Let's assume there's a student working with us. He also receives a laptop from our IT, and this working student probably, well, earns a bit of money with industrial espionage. So what does my report say? Here he is, the working student. He can manipulate data. He can steal data. Not nice. So what can we do against data theft and manipulation? Encrypt. We do select the boot application, activate data encryption, and sign our download with the certificates automatically with the certificates of the dev team. I do need the controller certificate for the boot application encryption, because I do encrypt this data, this file, with the private key of the controller. So I need to find the certificate somewhere. Well, you can't find it with the personal certificates, but with the controller certificates. Here we have the controller JS. That's the public part of the certificate, and thus the boot application is safe. So the problems are removed. Of course, here we have the point of laptop that can be, can be removed just by the fact that the IT sort of, well, clarified the whole laptop. That's what it looks like in threat modeling, and that's how it works. Let's have a bit more ambitious example. Let's assume we are a small company that produce cool gadgets locally, and they want to consider their footprint, their CO2 footprint, and want to keep that on a low level. Well, behind those boards we have 4 Raspberry Pi controllers that have a senset put on that, and this senset can, depending on the security level, display several colors. At the moment it's gray because I haven't had a threat model analysis run over it. So the company actually is set up in the way. They do have a factory floor where the production takes place. There are the 2 controllers for the value creation. Then there is an access for the engineers or the technicians. There you have maintenance personnel, etc. So trustworthy people. That's the reason why we have this local user here. Then around this trusted zone, this office complex, so it's office atmosphere, office environments. The people actually note down their passwords, stick it to their monitors. They probably have pictures of their cats, etc., but they are not very harmful. They are harmless. But on the premises of the company, there's also a weather station. And there, weather data are collected and assessed, but it's not decisive here. We said CO2 footprint plays a certain role for the company. They do have a small wind part on the island of Rügen, which is not on the premises of the company. That means the connection is carried out and established through the internet. That controller actually is an easy target to be attacked. Then there is a remote maintenance access or point where third parties have access to the controllers. So how is it depicted or mapped in CODESYS? I do have a project where the 4 Raspberries are mapped, and I hope we are connected to them, and I've already prepared a threat model. So we do see one-on-one a simulation or model of the system in the Threat Model Editor. Let's have a look at the report. What do we have to expect? Well, 38 problems we have. You do see that we do have a connection with the controllers, and I hope I see a color. Great, perfect. Well, green means everything is okay, is good. Yellow means somebody started to activate security features, so work in progress, that means. And red means it's totally open, we need to do something about it. We start with the red controller to get this thing under control. Why is that one red and why aren't the others? The controllers can be seen at the top part here. Closed, closed, closed. Okay, factory floor, 1, 2, and the weather station. They do have the latest software version installed. Great, 3 things we can check. But the wind generator, as we can see here, the software of that one is not up to date. Well, it's a problem because that one, the wind park, is not on the premises of the company, and therefore it's very easy to attack. So let's hide the 3 problems that are solved, actually. Then I sort in alphabetical order to get the wind park to the top. We do have some issues or problems that need to be solved. There might be attacks from the web, from the cloud, man in the middle. So, because of this internet connection, a hacker can get access to the wind generator or this wind park. Not so nice. What we also have is, we don't have, obviously, a user management. Unauthorized access is what we can see here. Those are things that can be solved with the Threat Model Editor. So I select the wind generator and have a look at the properties. So hardware failure, we do need backup and restore. Other than that, it takes us ages until the controller is running again if there is a failure. Well, we can't actually make a firmware update while the wind generator is running. So that is something that might not be possible. Man in the middle, encrypted communication, inactivated immediately. That's what we do. Operator mistake. Well, operating modes activated. Yes, that's what we do, because we do think about the cat, so that the remote maintenance program does not set a breakpoint, and also user management that needs to be activated, because that is actually first line of defense. That's what we always need. Let's have a look at the reports again. Now we've managed to get hold of 10 threats, and now it should be orange. Exactly. We will never ever get that green if there is an outdated firmware. Let's have a look at the 2 controllers on the factory floor. They are very decisive for the system because the value is created there. We will also activate the features there because it's very important. You see outdated software here, not a problem at all. Service Pack 13 is running on there already. Encrypted communication, that's essential. We need to get rid of the man in the middle because it's a obvious or potential threat. Interactive login is also what we activate. Because it can be the case that because you're in a hurry, you connect to the wrong factory floor controller, and therefore the interactive login is important. And of course, user management, that needs to be done. I do repeat that for the second controller. So the weather station is not so difficult. We'll just activate user management here. and also encrypted communication. Those are the two things you would want to use every time. So if you refresh the report, we see that there are 10 open points, and 2 controllers are now set in, or we've managed to get them in the green zone, so to say. The new threat modeling in CODESYS will facilitate analysis and operation. The user can see the progress of his work and will have an easier time in the future. We think that's a very important step in order to be well protected in the CODESYS world in the future. We saw that how you could analyze a system with just a few clicks and how you could raise the security protection to a certain level. Well, exception here, wind generator. The wind generator actually makes me worry because it's unprotected on the internet. Well, not really unprotected, but we have activated certain security measurements. We can't update a firmware in the running operation, but probably my colleague Mr. Greising has an idea what we can do. Thank you very much for your attention, ladies and gentlemen.